Okay, so in this video we're looking at the ticker tapes. So I've got 4 examples of ticker tapes, which are the tape that you pass through the ticker timers in order to look at the speed or any changes in the motion of a specific object. Okay, so the first tape that we're looking at up the top starts out with the dots pretty close together, and as the tape moves along, they increase in distance. So this is an example of a tape that shows acceleration. The second tape is the opposite to the acceleration tape. So dots are further apart and then they start to get really close together. So this is an example of deceleration or negative acceleration. So it's slowing down. The third tape is also an example of acceleration, but the gaps between the dots are much bigger and it happens a lot faster. So what this is still acceleration but with a greater force. So this object here has obviously experienced a greater force than the object up the top. Now the tape down the bottom shows constant speed. The dots are evenly spaced. So when we look at ticker tapes, normally there's a given time that it takes for the machine to do a dot here. So a dot here and a dot here. So there's normally a distance between these two, or there's normally a time. It could be about 0.02. Sometimes it's 0.01. It depends on the ticker timer. In order to calculate the speed that an object is going, using a ticker tape, what you have to do is measure the distance between two dots. So from about halfway through both dots, measure this distance, and then divide it. So remember, D equals S over T. So divide that, not D equals S over T. S equals D over T. So divide this distance by whatever the given time is between two dots. Okay, so say a question asks you to use a ticker tape to calculate the acceleration of an object based on the ticker tape timer. So what you need to do is, first of all, you need to remember the equation for acceleration. So A is V minus U over T, where V is the final velocity, so here, U is the initial velocity, so here, and T equals whatever they've given you. In this case, we're using, T equals whatever they've given you times the amount of spaces in between the dots. So in this example, there's 1, 2, 3, 4, 5, 6, 7, 8 dots. So it'll be whatever T is, so we'll say it's 0.02 times 8 spaces. So remember, the 0.02 is not for each dot. Don't count each dot. It's the space, the gaps in between the dots that you want to be counting. So say that this distance is 1.3 centimeters, and we're going to say that this distance is 1.5 centimeters. So first of all, you've got to calculate your V and your U. So V is equal to 1.3 centimeters divided by 0.02, which gives you 65 centimeters per second. So that's the velocity or the speed that the object was traveling at this point in time. U equals 1.5 centimeters divided by 0.02 seconds. So that gives you a speed of 75 centimeters per second. So if T equals 0.02 times 8, then that gives you a time of 0.16 seconds. So then you take all of these pieces of information and you just plug it into the formula. So A equals V minus U over T, which equals 65 centimeters per second minus 75 centimeters per second divided by 0.16 seconds. So that gives you an average acceleration over for this piece of ticker tape of negative 62.5 centimeters per second squared.